Page 12. Consider the point 3, -1, and 4. Draw a diagram to locate the point of t in space. Now remember from the previous page, a 3D graph kind of looks like this. So there's like the x, and then there's the y, and then there's the z coordinate. And so you kind of draw three-dimensionally like that. Now remember how I always say that art is very important to math. So let's see, first I'm going to draw the axes. So we have the x-axis, the y-axis, and then the z-axis, like that. X, y, and z. So we're going to find the point t in the space. And so first we're going to assign a color to each one. So we'll say x is red, and y is green, and z is blue. And then we're going to draw with these colors 3 units, 1, 2, 3 units, and then we're going to do green, we're going to do -1 unit, so that means like instead of going to the right it goes to the left, and then 4 units up, 1, 2, 3, 4. So the point in the end is located right there. Okay, that's the point T, and of course O is the origin. So the vector OT looks kind of like that. Okay, and it says find the vector OT, so you could write that as a component vector. You could write 3, -1, 4, or you could write 3i minus 1j plus 4k. Okay, either way. How far is it from O to T? Okay, to do that you would use Pythagorean Theorem. You would take, so you would have OT, and the distance OT you can find by taking the square root of the x component of the vector plus the y squared plus the z squared. So you just do that. So you have like 3 squared minus -1 squared, which would be plus 1 squared, plus 4 squared. You're going to take the square root of that, which would be equal to the square root of 9 plus 1 plus 16. So that would be 9 plus 1 plus 16 would be 26. So it would be the square root of 26 would be the distance from O to T. Okay. Given the vector A, or given the point A, -3, 1, 2, and the point B, 1, 0, -1, find AB and BA. And the way you find AB and BA, it looks kind of like the same thing, but one's in one direction, one's in the other. What we're going to do is we're going to find, we're going to take the vector from B, 1, 0, -1, and then we're going to subtract the vector for A, -3, 1, 2, and that's how we're going to find AB. Now BA is just the opposite. We're gonna do the exact opposite direction, -3, 1, 2. We're going to take the A vector and we're going to subtract the B vector, 1, 0, -1. Okay, so let's see. AB would be, let's see, 1 minus -3, which is a 1 plus 3, which is 4. 0 minus 1, which would be -1. -1 minus 2, which would be -3. Okay, so that would be AB. And then what about BA, vector BA? So it would be -3 minus 1, which would be -4. 1 minus 0, which is 1, and 2 minus a -1, which would be 3. And you can see that these two vectors are exact negatives of each other, which makes sense because AB vector is the negative of the BA vector. Okay, and then we're going to find the lengths of the AB vector and the BA vector. So the way we do that is we use Pythagorean theorem. So we take 4 squared plus -1 squared plus -3 squared. Okay, And this is 16 plus 1 plus 9. And hey, what do you know? It is the same as number 1. It's square root of 26. Okay? And if you notice, regardless if you do 4 squared plus negative 1 squared plus negative 3 squared, or if you do this one, which is negative 4 squared plus 1 squared plus 3 squared, you still get square root of 26. So square root of 26 is the answer for both the distance or the length of vector AB and the vector BA. Okay? Number 5. Given these two points, M and N, find the position vector M relative to N and the position vector of N relative to M. So the position vector of M relative to N would be the vector NM, and the position vector of N relative to M would be MN. So for NM, we would take the M vector and we would subtract the N vector. And for MN, we would take the N vector and subtract the M vector. And it's kind of confusing because everything's like reversed here. So you've got to figure out some way to remember that. So M minus N would be 4, negative 2, negative 1, minus negative 1, 2, 0, which would be 4 minus negative 1 would be 5. Negative 2 minus 2 would be negative 4. Negative 1 minus 0 is negative 1. And N minus M should be the exact opposite of that. Let's start from scratch just to make sure we didn't make any mistakes. Negative 1 minus 4 is negative 5. 2 minus a negative 2 would be 4. And 0 minus negative 1 would be 1. So negative 5, 4, 1. Exactly the negative of the other, which is exactly what we expect. Okay? And what about C? It says the distance between M and N. So we could take either one of these, and we take the square root of 5 squared plus 4 squared plus 1 squared, and that would be equal to square root of 25 plus 16 plus 1. Okay? And so that would be equal to 25 plus 16 plus 1, using the offline calculator I get, square root of 42. Square root of 42. Okay, so that would be the answer to part C. 7. Find the shortest distance from the point 3, 1, negative 2 to the y-axis. Okay. It might help you to draw a picture. Okay, we were using the colors red, green, and blue. So why don't we do that again? So we go, red is 3, green is 1, and then the z coordinate is negative 2, so 1, 2. And then it says find the distance, find the shortest distance from this point to the y-axis. Now remember, the y-axis is this axis here. So we're actually finding the point between that point and here, and it makes kind of a triangle, you can see. And this triangle that it makes is, let's see, this black part here is 3 long, as you can see, and the blue part there is 2 long. So what they want is this distance here, which using Pythagorean Theorem would be 2 squared plus 3 squared square root. So that would be 4 plus 9 square root of 4 plus the square root of 13. Okay? So the distance from this point to the y-axis is square root of 13. What about the distance between this point and the origin? Okay, well that's just using Pythagorean Theorem in all 3 dimensions. So that would be the square root of 3 squared plus 1 squared plus 2 squared, which is equal to square root of 14, square root of 14, okay. Find the shortest distance from point Q to the YOZ plane, the YOZ plane. So the YOZ plane, I guess, would be the plane which connects the y-axis to the z-axis. And remember, the y-axis and the z-axis, that would be, let's see, the y-axis is this one here. And the z-axis is this one here. So the yz axis would be like the yz plane, yoz plane would be this axis. So the distance from the Q, now you can see why you have to be good at art. The distance from the point Q to the yoz plane is this black line here. And you can see from the drawing that it's 3. The distance is 3. Okay. All right. I'm just going to move this drawing over a little bit because to get it out of the way of these other things. Okay. And I'm going to move this back. Okay. Moving on to number 9. Use side lengths to classify the triangle ABC given these coordinates. Okay, so it's giving us 3-dimensional coordinates for points A, B, and C. And we're going to decide whether these triangles are, I think, certain types of triangles, I guess. And I guess there's 2 ways of doing that. One is with side lengths, and the other is with angles. I think it's a little bit easier to do with side lengths. So how about if we do that? We're going to figure out what the side lengths are for AB, BC, and AC, and based on that, we'll try to figure out what kind of triangle it is. Okay. So let's see. AB, we would figure out the distance from A to B. So that would be basically square root of 2 squared plus 8 squared plus 2 squared, because the difference between 1 and 3 is 2. Okay, so we'll put square root of 2 squared plus 8 squared plus 2 squared. Okay, and that would be 4 plus 4, 8 plus 64, 72 would be the square root of 72. Okay, and then BC would be, let's see, the square root of 17 squared minus plus, let's see, we could just make everything positive because I'm sorry, that would be 2 squared and negative 2, 11 squared. Okay, so that would be let's see, 17 squared plus 2 squared, which is 4, plus 11 squared, which is 121, 414, square root of 414. Okay, and then we're going to find AC. So AC would be, let's see, the square root of 18 minus 3, which would be 15 squared, 6 minus 0, which would be 6 squared, and negative 9 minus 0, which would be 9 squared. So that would be, wow, 225 plus 36 plus 81, which would be 342. Now, this might not at all be obvious, but if you take these 2 shorter sides, square root of 72 and square root of 342, and if you think of them as the legs of a right triangle, so you'd say, oh, 72, square root of 72 squared plus square root of 342, let's see what you get. So I'm going to square 72, I'll get 72, square of square root of 72. Then I'm going to square the square root of 342. I'll get 342. I'll add them together. Hey, what do you know? 414. So this squared plus this squared equals this squared, that is Pythagorean theorem, which means that AB and BC are right angles to each other. This is a right triangle. Okay, so it's a right triangle. All right, what about B? Okay, since it's a book problem, of course we're going to get something nice and neat like that. So AB would be equal to square root of 1 squared plus 2 squared, 4 plus 3 squared, 9, okay, to square root of 14. And then BC, I would get square root of 4 minus 2 squared plus 6 minus 2, 4 squared plus 6 squared, which is equal to 36 plus 16 plus 4, which is 36 plus 20, 56, square root of 56. Okay, and then AB, BC, and the last one is AC. So AC is equal to 4 minus 1, 3 squared, 6 minus 0s plus 6 squared, 6 minus a negative 3, 9 squared. Wow, that's a big number. So 81 plus 36 plus 9, square root of 126. Okay. Let's find values for all these. So square root of 14 is about 3.74. 3.74. Square root of 56 is about 7.48. Square root of 126 is about 11.22. And what we're going to notice here is that, look at the length of these sides. 3.74 and 7.48. Those are pretty long for to have a, oh, look at that. If you add these two together, you're going to get exactly 11.22. So if you have two sides of a triangle that are, you add them up and they're the exact same length as the third side, basically you don't have a triangle, you have like a really flat line, right? So this is like a flat triangle. I don't know what you call it, a flat triangle, or maybe like a straight line or something. Okay, so that's a bizarre triangle there. Okay, moving on to 11. A sphere has a center, -1, 2, 4, and the diameter AB, where A is -2, 1, 3. Find the coordinates of B and the radius of the sphere. Okay, so basically what they're saying is the center is at -1, 2, 4. So I'm going to use my coordinates here, red, green, and blue, and I'm going to draw that out. So -1, -1 would go backwards. So I'm starting from my origin right here, and -1 goes backwards. And then green would be 2 out that way. And then blue would be 4 up. 1, 2, 3, 4. Okay, and so that is my C, my center. And then A would be, let's see, -2, so it would be 2 back, and then it would be 1 up, or 1 to the right, and then it would be 3 up. 3 up, so 1, 2, 3. Okay, and then, so they're saying where is the opposite point from there? So this is really hard to see on this drawing, isn't it? Okay, so basically what they're saying is, okay, there's a point C, which is the center, and then there is a point A, which is a diameter, and so basically they want you to figure out, okay, where is point B? And so we know the coordinates for C and A, but we need to know the coordinates for B. So the way you're going to do that is you're going to figure out like the vector. You're going to figure out the vector A, right? And then if you figure out the vector CA, then you're just like add or subtract that vector to position C, and then you'll find position B, okay? Because the vector AC would be the same. Well, let's do it the other way. So like from, okay, let's have this. So we have vector C, we know A, and we want to find B. So if we figure out what vector AC is, and we add it to position C, then that should give us B, right? So let's figure out what AC is. AC is equal to the C coordinate, negative 1, 2, 4, minus the A coordinate, which is negative 2, 1, 3. Negative 2, 1, 3. So that's equal to negative 1 minus negative 2, which would be negative 1 plus 2. 2 minus 1, which is 1. And 4 minus 3, which is 1. 1, 1, 1. Okay. And so if we add the vector AC to C, then that will give us B. So let's see, we have the position negative 1, 4, negative 2, 1, 4, negative 1, 2, 4, which is the position C. We can add the vector 1, 1, 1, and then we should get the vector that, or the position B, which is going to be 0, 0, I'm sorry, 0, and then 2 plus 1 is 3, and then 4 plus 1 is 5. So the answer to coordinates of B would be 0, 3, 5. 13. Find ABC if A minus 4 equals blah, blah, blah. So these are just a bunch of algebra equations, right? So, so we know that A minus 4 equals 1. So that means A equals 5, right? B minus 3 equals 3. So we know that B is equal to 6. C plus 2 equals negative 4. So that means C equals negative 6. We subtract 2 from both sides. Okay? Last one. A minus 5. Oh, these are harder. A minus 5 equals 3 minus A. Let's see. We'll add A to both sides. We get 2A. 3 plus 5 is 8. Okay? A equals 4. Okay, and then what about B? So B minus 2 equals 2 minus B. 2B equals, let's see, we're add 2 to both sides, we get 4. B equals 2. Okay, C plus 3 equals 5 minus C. 2C equals 2, and C is equal to 1. Okay? These are just algebra equations, because if you have two vectors equal to each other, then the x, y, and z components, or the I, j, and k components, have to be equal to each other also. So you just solve 3 algebra equations. That was a tough page.